Hello, Highlanders. How's everybody doing? I know you can't answer that. I hope you're all doing well. We're coming down to the end for our few seniors that we have. We do have a few seniors that this will be the last thing they do this year in their honors pre-calc class. So just so that you know, I will miss all of you. So what we have this week is the chain rule, and then we're also going to incorporate some trig derivatives. So we'll start with the chain rule, and the chain rule was brought about when we're dealing with composite of functions. So for example, let's say we have a function that looks like 3x squared plus 4 to the fifth. So what we have are two functions that form f. We have the inner function, and then we have the overall outer function. So what we do is we call this inner part u. We call this u substitution. So the idea here is the new function f of u is going to be u to the fifth. So we've compacted it, right? We've taken our two functions and we have compacted it into one, and now we're going to take the derivative of u. So here comes the chain rule, and again, you have notes that I gave you last time, which are somewhere. Here they are. So this is the chain rule. So if you notice, this whole dy, du, du, dx, this means the derivative of y with respect to u multiplied by the derivative of u with respect to x. And remember, u is the inside function. Y is the outside function. So this derivative of the outside function times the derivative of the inside function, which is really what we got going on here. And the example is done with cosine involved, so we'll come back to that. But the key is, when you apply the chain rule, it's the derivative of the outside function times the derivative of the inside function. So basically, when we start to do the derivative of this, we are going to look for f prime of u, which, again, it's just the power rule. So we're going to have 5u to the fourth, because we multiply in front, drop the power 1, times the derivative of the inside function. So we got to remember what u is equal to here. U is 3x squared plus 4. So we continue, we can plug that into here. So we get 3x squared plus 4, that's u, to the fourth. And then we have to multiply that by the derivative of the inside function, which is just u. So the derivative of 3x squared plus 4, again applying the power rule, is going to be 6x to the first. So when you have a composite of functions, you need to use the chain rule. And we can multiply these together if you want to. And when you get good at the chain rule, you'll kind of skip this intermediate step of saying what's u and what's not. And again, you could have a chain of a chain of a chain. And you also have to remember that within these functions could be, you could have quotient things going on, you could have product things going on, so you have to apply those rules as well. So it could be more complicated than just having a simple composite. All right, let's take a look at another quick example. So f of x equals, let's look at the fourth root of 4x to the third plus 3x squared. So again, now we have a polynomial function inside of a radical function. So again, this is a composite, and we need to take a look at turning this into an exponent, just like we did in the previous lesson. So we're going to rewrite this as 4x cubed plus 3x squared to the 1/4 power. And now, because we have that, that's going to become my inside function, so I'm going to call that u. And then I'm going to rewrite f of u. Sorry, I'm doing that on purpose. I would do that in class too, and everybody would chuckle, but that's okay. So this is the outside function. And then again, u is the inside function. So applying the chain rule, and again, if we were doing this in class, I would be playing that great tune, Chain of Fools by Aretha Franklin, which if I were going to sing for you, it would be chain, 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 and you would have that going on. If you want to play that in the background for yourself, you can Google it. But anyway, the chain rule, again, the derivative of the outside function. So we take the derivative of this, which is 1/4 u to the negative 3/4. And again, that's just straight power rule, times the derivative of the inside function, right, which is u prime. So it's f prime u. So if we take a look at this, right, this is what I did. I did f prime u, u prime. Okay, that is the chain. And it's so cool, it's off the chain. I'm sorry, I'm in a weird mood today. All right, anyway, so we can plug u back in here. So the derivative is 1/4 of u, which is 4x cubed plus 3x squared, times the derivative of u, which is 12x squared plus 6x. So again, it's an application of the power rule, but when we're dealing with composite functions. And then if you wanted to, you could multiply that out. But for our purposes, we are done. So this is the derivative of this. Okay, let us get to a more challenging example. Let's see. Let's do one where we have, let's go x cubed plus 3x squared minus 4x plus 5 to the 4th power over 3x squared minus 2 squared. So, in stepping back for a minute and taking a look at what we have got a quotient. So like I said in the last video lesson, when we were doing the quotient rule, you're going to need to let that guide what you do. And then within the numerator and the denominator of this particular function, we have composites going on. So we're going to need to apply the chain rule when we go to differentiate that. But again, the overall order of operations here is being controlled by the quotient rule. It tells me what to do. So this being me, I'm going to write this out. So I'm going to follow the quotient rule first, which means, remember the quotient rule, it's the derivative of the top times the bottom minus, so the derivative of the top. So I'm just going to write it out. I'm not going to actually do the derivative yet. So this is the top function. So I'm going to take the derivative. That's what this means. Putting that little prime there means I still have to go back and find that derivative. So the derivative of the top function times the bottom function, and this is coming from the quotient rule, minus the top function. I shouldn't have made this so long, but that's all right. Times the derivative of the bottom. And again, I'm not going to actually do that. I'm just going to write it in here. that I need to go back and do this. And again, that's all over the bottom function squared. So it's derivative of the top times the bottom minus top times the derivative of the bottom all over the bottom squared. So the quotient rule is telling me the order in which I need to differentiate or find the derivative of. And now I'm going to go back and actually do that. So again, we have to chain this, keeping in mind that this becomes the inside function. So I've got to do the f prime of x is going to be f prime u prime, that's this, times 3x squared minus 2 squared minus this whole thing, so x cubed plus 3x squared minus 4x plus 5 to the fourth, times the derivative of this, which again we've got to chain that. So I've already used u, so I'm going to go ahead and change it up and do v. So now the derivative of this through the chain rule is going to be f prime of v prime, and that'll be that guy, all over my denominator squared. Okay, so it helps if we write in f of u, which is u to the fourth, and f of v, which becomes v squared. So continuing on, the derivative of this becomes 4u cubed, applying the power rule, and then the derivative of u, which remember this is u, is 3x squared plus 6x minus 4. That's straight up power rule. That's all we're doing, right? So that's this piece times this, which is 3x squared minus 2 squared, minus this, now we're going to do the derivative here. So I take the derivative, f prime of v, which is 2v to the first, times v prime, which is the derivative of this guy, which is going to be just 6x. And again, that's all over this, which I can write as that. So the only thing left to do now, since I'm done differentiating everything, I'm going to have to go back in and plug in u and v, and then I'm done. So this becomes 4, remember this is u here, right? So x cubed plus 3x squared minus 4x plus 5 to the third. So that's that times this times that minus x cubed plus 3x squared minus 4x plus 5 to the fourth times 2 times v, which is 3x squared minus 2 times 6x. And again, so this is the derivative of f. A lot of work, but again, keeping in mind that what we're looking for here is when we have a quotient to let the quotient rule dictate the order in which we are going to differentiate. And that's why I kind of write it out with the quotient rule, and then I go back, and if I have to chain it or whatever I have to do to find the derivative of that is what I need to follow. And in this case, it was the chain rule twice, and I just kind of set it up that way to practice the chain rule. Again, do you guys need to write all this stuff out eventually? No. I think at first you should, just to keep track of what's going on. and if you have a product, the same thing. Let the product rule dictate the order in which you differentiate, and then go back, and if you have to chain anything or whatever, you follow that particular rule. One other thing, so when we move on into some applications of these derivatives, if we were trying to solve this guy, it would make no sense for me to multiply all this out. If you notice, we've got two terms here separated by this minus sign, and what I have here is 3 of these here and 4 of those. So I can factor out the 3 of these, and I've got these that I could also factor out. So if I were simplifying this, and this is kind of important, this is the algebra piece, I would factor out the x cubed plus 3x squared minus 4x plus 5 to the third, which is going to eliminate that here. And I would also factor out the 3x squared minus 2, which is going to eliminate that one there, and drop this to 1, drop this to 1. And then what is left? We have a 4. We have a 3x squared plus 6x minus 4. We have a 3x squared minus 2 minus, we have an x cubed plus 3x squared minus 4x plus 5, and a 12x all over the bottom. So, again, notice the idea here is if we were trying to find a maximum or a minimum, right? So if I've got this particular function that's doing something, right, and I'm looking for this or I'm looking for that, this being your max, this being your min, the idea is those tangent lines have a slope of 0. Remember what the derivative is. It's the instantaneous rate of change. It tells me the rate at which the function is changing, and so we're looking for those points. Those are key or critical points. So I would want to set this to 0. So keeping in mind, when we're looking at rational functions, the only time or the only thing I care about is when the numerator is 0, because the denominator doesn't matter. So by factoring, I now have a triple 0 here. Not a triple 0, but I do have 3 zeros here. Got 2 more here, and then I'd have to clean this up. So yeah, you would have some heavy-duty solving to do, but you could then locate those zeros and find out where this function has a max or a min, etc. Okay, let's look at one more chain rule before we move on to our trig derivatives. Let's see. Okay, so we have, I'm going to do this is a problem from one of your worksheets that I'm going to do with you, and it is the square root of 7x plus 3 over the square root of 9x squared plus 2x minus 5. So again, we have a quotient. So I'm going to allow the quotient rule to tell me what to do. So I'm going to write it out. So f prime of x, according to the quotient rule, derivative of the top times the bottom minus the top function times the derivative of the bottom all over the bottom squared, which is really just this, because the square and the square root cancel out. So now I've got to do these two derivatives, and again, because that's a power and inside we've got polynomials, we have to chain because it's a composite. So again, I'm going to let this be u, and I'm going to let this be v, so that f of u becomes u to the 1/2 power, because it's square root, and then f of v becomes v to the 1/2 power. Alright, so now see if you can follow along. And again, I would suggest You trying these on your own, stopping the video, see if you come back with the right answer. But remember the chain rule, right? So we're going to do f prime u, u prime, and the same thing here, f prime v, v prime. So the derivative of this becomes 1/2 of u, which is 7x plus 3 to the negative 1/2, right? And that's just the derivative of this, 1/2 u to the negative 1/2, times, and that's the outside function, times the derivative of the inside function, which is just 7. So that's the first part, times this guy, and I'm going to write it as using fractional exponents. So that's the first part. So we took the derivative of this, we chained it, minus this, which is 7x plus 3 to the 1/2 power. And now the derivative of this guy, again, the derivative of the outside part is 1/2 v, which is 9x squared plus 2x minus 5 to the negative 1/2, times v prime, which is 18x plus 2. All over 9x squared plus 2x minus 5. So we see that we have the actual derivative, right? And again, I skipped the little step where I did 1/2 u to the negative 1/2, because that's what this is right here. I just plugged the u in as I went. And that's what you'll start doing. You'll start doing the chain rule in one single step. Like you might even do it up here. But again, I'm still writing it out for you guys so that you can see it. And then, if I were going to solve this, I've got two terms again in the numerator, and I'm going to factor out the 7x plus 3 to the negative 1/2, and I'm also going to factor out this 9x squared plus 2x minus 5 to the negative 1/2. Now watch what happens. When I pull this out of this first term, that's gone. So I'm left with 7/2 times 9x squared plus 2x minus 5 to the 1/2 minus, this comes out, so that's gone. Oh, sorry. Let me back up for a second. So when I take this right here and I divide it by this, right? You got a 1/2 minus a minus 1/2. This becomes a 1. Right? So let me do that one more time. So remember, I'm factoring. First thing I'm doing is factoring this out, which leaves out of here. And then this is also coming out. So this divided by this, because the bases are the same, we subtract the powers. So a 1/2 minus a minus a 1/2 becomes a 1. And here, this divided by this guy also turns that exponent into a 1, because it's 1/2 minus a minus 1/2. This goes away, times a 1/2 times 18x plus 2, all over this 9x squared plus 2x minus 5. So let me show you what happens now, because I took the negative powers out, and this will always happen because of the power rule. Like if this were to the 2/3 power, you would have that negative 1/3, and you factor that out. You know, whatever that rational, or that that rational exponent is when you're doing your radicals, they're always going to add up to 1 like this, because you subtract 1 when you do the power rule. So the nice thing about these is being the negative ones, we can shove that down into the denominator. Again, why is that nice? Because what does that do for me? It allows me to ignore the denominator when I'm looking for zeros, because the zeros come out of the numerator. So what do I have left? I have 7/2 9x squared plus 2x minus 5 minus 7x plus 3 times 9x plus 1 over, and you got this guy, which is 7x plus 3. Now it's to the positive 1/2 down below, 9x squared plus 2x minus 5 to the 1/2, and then your 9x squared plus 2x minus 5, which, if you wanted to, you could combine those by adding the powers. But again, why doesn't that matter? Because when we're looking for max and mins, I only care about what's going to make my numerator 0. What's going to make this 0? And if you notice, foiling that out is going to make this a quadratic, this is a quadratic. We've got nothing but a quadratic up here. So really all you're solving is a quadratic equation. And that's it. So this factoring piece becomes more and more important for you. You did some of these, I hope you did some of these problems last year in Honors Algebra 2. But if not, again, you're always factoring out the smaller value here, the smaller exponent. The negative exponent is going to come out. Or if it's, if it was like the one we did a minute ago, what did we take out? We took out the smaller power because that was a 4, that was a 3. Factor out the smaller one. Okay? All right, so next. In your Google Classroom assignment, you will see this document. These are your trig derivatives. So these tell you what the derivative of each of these particular guys are. And again, early on, we derived these. And I should note right here is that all of these product, quotient, chain rules, these derivatives, they all come from the difference quotient. Right? They all come from the process of using that limit as h goes to 0. So all of this stuff stems. So these are kind of like shortcuts, which is what we're doing right now, that power rule and everything else. So derivative of sine is cosine. The derivative of cosine is negative sine, etc. So you want to have this with you. Normally I would make you memorize those, but obviously we're not testing. So keep this nearby. But you should know these, right? You'll need to know them for next year. Okay, so this is a case where you don't use power rule here, right? You just have set derivatives. So let's take a look at an example. Let's say my function is sine x times tangent x. And I want to know the derivative. So since we have a product, we're going to allow the product rule, or let the product rule dictate what we do. So writing it out using the product rule, I'm going to do the derivative of sine times the tangent plus, remember it's the derivative of the first times the second, plus the first times the derivative of the second. So the sine x times the derivative of tangent. So continuing, we have the derivative of sine, which is cosine. All right? So the derivative of sine, so that becomes cosine x tan x plus sine x times the derivative of tangent, which is secant squared. So that would be the derivative of this particular function, and it looks like this. And if you wanted to take it a step further while you're simplifying, since tangent is sine over cosine, this is just going to be sine x plus sine x secant x, secant squared x, and then if you wanted to, factor out the sine, you got 1 plus secant squared. And if you were looking for zeros, looking for max, mins, etc. So all your trig work, all of your algebra, all coming back into play, right? Those are the tools that help you function here. All right, so what if we had the cosine of 3x? It's a new example. So if we have the cosine of 3x, remember this, the derivative of cosine x is negative sine. It doesn't say 3x here, right? Remember, that would be 3 times the angle. So what we have to do here is we have to think of this as a composite function, because my angle, theta here, is not just theta, it's 3x. So we're going to let this be theta, and so now we have f of theta, which looks like cosine theta. And because it's a composite, we need to chain it, right? So again, remember the chain rule, simply derivative of the outside function times the derivative of the inside function. So this becomes f prime theta times theta prime. Or, in this case, the derivative of f of theta, so the derivative of cosine is negative sine. So this becomes negative sine theta times the derivative of theta, which is just 3, because theta is 3x. So then we can go ahead and plug that back in. Theta is 3x times 3, or negative 3 sine 3x would be your derivative. So anytime something else is going on here, you have to chain. So if your angle, becomes whatever. I mean, this could be a polynomial of something higher degree, or you might have it be. Let's take a look at what I'm talking about here. So what if we have? Let's go cotangent of 3x squared minus 4 squared. Okay, so now we've got some things going on here, because what we have inside is actually a composite, and then the whole thing is a composite. So we have a composite of a composite, which means we're going to have to double chain. So what I'm going to do here, I'm going to pack everything up. So let's call this V. That's the inside function of the angle. And then the whole angle we're going to call theta. So f of theta is the cotangent of theta. All right. And then f of v is really the square. That's that inside function. So, again, we chain this, start with the outside function, so we get f prime theta times theta prime. And so the derivative of the outside is, and again, it's cotangent, so that's negative cosecant squared. So we have negative cosecant squared theta, and theta is 3x squared minus 4 squared. Alright, so that's taking care of the outside. Now we got to do theta prime. And what is theta? So now I need to take that 3x squared minus 4 squared and find its derivative. Okay, so now this also needs, this is where the second chain comes in. So we have negative cosecant squared times, and now chaining this, remember this becomes 2v to the first when we find the derivative. So it's f prime v, v prime. So that becomes 2v to the first times v prime. So 2 times this to the first, right? That's this 2v to the first, which is the derivative of the outside function, times the inside function, which is v prime, which becomes 6x. So we end up with, if you wanted to, you would have negative 12x. That's this times this times this, times 3x squared minus 4, times the cosecant squared of 3x squared minus 4 squared. and that would be your derivative. So again, if you've got multiple composites going on, you're going to have to do the same number of chains along with that. So what helps, again, is so it isn't so confusing, pack it up, follow your chain, right? Derivative of the outside times the derivative of the inside. Recognize what theta is, what v is here. That allowed me to get this. So f prime of theta is just this. And then I got to go ahead and find the derivative of theta, which happens to be another chain. Anyway, hopefully that helps you. Again, this is there for you guys to look at and to use. So that's the chain rule. We have the derivatives of the trigonometric functions. And for you seniors, that is it as far as notes from Mr. Lampkin this year. I'll take this time to wish you all well. It's unfortunate that you guys miss out on a lot of your end of the year festivities like prom and graduation and all of that, all those good things that we get to celebrate. So hopefully for you guys that I will get a chance to see you again. I want to know, I like to know where you end up college-wise and what you're doing. And so when things are safe and back to normal, please come back and visit me. I appreciate having you guys in class. You guys have done a nice job all year long. So with that, I will bid you all adieu until next time. Also, seniors, if you want, and you're still in quarantine and not doing anything, and you want to come back for the Max Min stuff we're doing next week, feel free. If you just want to, look at the lessons, hop in, take a look, whatever, that's up to you. It's stuff you're going to do in calc. It's application of all this stuff. I kind of hinted at it here, so feel free to join in on those lessons and stick around. We're going to end up doing chapter 11 with the underclassmen last 2 weeks. So that's all. Have a great day, Highlanders.